Welcome to this tutorial on calculating square roots in NumPy. Today, we'll explore the np.sqrt function, which allows you to compute square roots element-wise across arrays. This is one of the most commonly used mathematical functions in NumPy for scientific computing and data analysis. np.sqrt is a NumPy function that calculates the square root of each element in an array. The beauty of this function is that it works element-wise, meaning it applies the square root operation to every single element in your input, whether it's a single number or a multi-dimensional array. Mathematically, it computes the square root of x for every x in your array. The syntax for using this function is straightforward. You simply call NumPy.sqrt and pass in your input x as a parameter. Here, x can be a single number, a one-dimensional array, or even a multi-dimensional array. The function will automatically handle the dimensionality and return results in the same shape as your input. Let's start with the simplest case, finding the square root of a single number. First, we import NumPy as np. Then, we call np.sqrt with the value 16. When we print the result, we get 4.0. Notice that the output is a floating point number, even though our input was an integer. This is the default behavior of NumPy's square root function. Now let's see how this works with a one-dimensional array. We create an array containing the values 4, 9, 16, and 25. When we pass this array to np.sqrt, it calculates the square root of each element independently. The result is a new array containing 2, 3, 4, and 5, all as floating point numbers. This element-wise operation is what makes NumPy so powerful for array computations. The function works equally well with multi-dimensional arrays. Here we have a two-dimensional matrix with 2 rows and 3 columns. The first row contains 1, 4, and 9, while the second row contains 16, 25, and 36. When we apply np.sqrt to this matrix, we get back a matrix of the same shape with the square roots: 1, 2, 3 in the first row, and 4, 5, 6 in the second row. The shape and structure of your array is preserved. There are 3 key points to remember about np.sqrt. First, it returns float 64 values by default, which means you'll always get floating point numbers in your output. Second, the function works with any numeric array type, including integers, floats, and complex numbers. Third, and this is important, if you pass negative values, NumPy will produce none, which stands for not a number, and you'll receive a runtime warning. Let's see what happens with negative values. We create an array with 4, -9, and 16. When we compute the square root, the positive values give us 2 and 4 as expected. However, the -9 produces none, and NumPy issues a runtime warning about an invalid value. This is because the square root of negative numbers is not defined in the real number system. If you need to work with negative numbers, consider using NumPy's complex number support or handle the negatives separately before applying the square root function.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.